So there's our Vertex format. And again, if this did not come in its Vertex format, we would have to use completing the square, which we haven't done yet, but I assume we will eventually. What I have here is my vertex to start with, and that's good because we need the vertex when we graph these on the assignment. Also for graphing my hand. So I can see that the h is just a regular 5. Again, the minus sign doesn't really go with it. It's just part of the format. And then the k here is positive 3. We know that because it's a plus 3. So let me get that on the graph at 5, 3, which would be, for me, right here. Now, I'm trying to be careful with where I put my labels, right? 5, 3, I'm putting it up here because I know this one opens downwards. How can you know that already? It's because this is a negative a right there in front. In fact, it's a negative 1, which tells us, the a value being negative tells us it's going to open downwards. Okay, well, that's fine. But I still need some other points. Oh, I just put my vertex down here, right? Also, my axis of symmetry is always x equals whatever the x value is in the vertex. You could say h, but it's 5, yeah. So let me see if I can get that on the graph as well. That's decent. It's pretty good.
Then we have an arrow at both ends.
All right. Well, I'm going to use a calculator to find my x and y values. Now, I'm going to make my table, so I got my x and y's. I'm going to set this up for several values, 4, I guess. And again, I only need to do one side of the line. Doesn't matter if I go to the left or the right. I tend to just kind of drift towards wherever 0 is, and that means for me it's to the left, and then just reflect, because 0 is a very easy number to work with. Will I get to 0? Probably not. And that's okay that I won't. But I'm just going to go to the left, so I'm going to go downwards in my x's. So I'm going to go 4, and then 3, then 2, then 1. Let's see how far that gets us. But again, I'm just plugging this into the calculator. So I'm going to say in my calculator first, 4 store for x. So I got x, 4 stored for x, then I type in my equation. Negative, parentheses, x minus 5, close parentheses to the power of 2 plus 3, enter, boom. Yeah, it's 2. So 4, 2 would be 4, 2 right here. Okay, so let's do 3. So I say 3, store for x, enter. I go back up to my equation, press enter, enter, and it says your x, or your y value rather, is negative 1. So that'd be 3, negative 1 here. Okay, let's try 2. 2, store for x, enter. I go up back to my equation with the x, I push enter, and I get negative 6. 2, negative 6, which is down here. That means 1 isn't going to make it. I still want to see what it is, though. So 1 store for x, I go back up, I push enter. Now, if you don't have the storage thing down, that's okay, but I get negative 13. So that would be, somewhere down here. I'm not going to label it because it's not on the graph, and I'm just approximating that value. Now, once again, we go back and we say, well, the other side of that axis of symmetry is just, the axis of symmetry is going to reflect those. And so what I'm going to do is, well, reflect them. Okay, so this one, for example, is 1 to the left of the axis of symmetry, so I'd go 1 to the right. That appears to be at 6, 2. And then this one, 2 to the left, so 2 to the right would be its reflection. That appears to be at 7, negative 1. And then again, 3 to the left, so 3 to the right here, that would be at 8, negative 6. And again, that's all I can fit on this one. Well, we're down to graphing the actual parabola. Here we go. All right. Boom. Oh, that was decent for me. Let's try the other side then. Ugh. Sure, whatever. Okay, well, that's my parabola. It opened down just as we figured it would. Now the table right here. Let's take a look at a different way to find a table. And by the way, I did use my calculator to create that table right there, and it was probably more enjoyable than it should have been. But I'm going to make another table here. Okay, so I want my x and y's right here. This is also known as calculator method. Here's what we're going to do to use this calculator method, and I'm going to show you the button progression on this. So if you want to follow along, you can. So the first thing I'm going to do here is I'm going to push the button that's called, remember how we were making a table? I push the button on the calculator that says table. Now I push table and it says y equals. So in my table, I'm going to type in, because it's already showing y equals, so I'm going to type in negative parentheses x minus 5 close parentheses squared and then plus 3. This is what I'm going to type in, then I'm going to push enter. So I got that in, I push enter. Now on my screen it says start, and right now mine's saying 0. It says step, mine's saying 1 right now. And then below it says auto and ask X, and then at the bottom right it says okay. That's the okay part's all we're worried about. So where do I want to start? It doesn't matter. I'm going to go to the lowest value on my table. So I'm going to say, this is arbitrary by the way, I'm going to say X is 1. Okay, start, this is saying start where X is 1. And I want to go in steps of, this is asking for the scale. So see in my table over here how I went up by 1 every time? If I went up by 2s, then my steps would be by 2s. But since I'm using going up by 1s, my step, for me, is 1. Okay, so I say 1, enter, I put a 1 there already. It says mine goes straight to auto, I push enter. It goes straight to okay, I push enter again. And on my calculator right now, it shows this. 1, negative 13, 2, negative 6, and 3, negative 1. Now, if those values don't seem familiar, just refer to them over here, right? We had 1, negative 13, 2, negative 6, 3, negative 1. And if you scroll downwards, if I go down to 4, it shows 4, 2. If I go down more, it says 5, 3, which was our vertex. And if I go down again, I would expect to see 6, 2. Boom, it says 6, 2. If I go down again, 7, negative 1. Down again, 8, negative 6. The calculator did all that work for me just like it did before, but I used the table function to do it. And now, is this a good way to find the vertex? You could say that you could, I suppose. But generally speaking, we use this way right here.
Is this just another?
Yeah, so I like this calculator method stuff because even though I was using storage even for this one, so it wasn't as much typing, this is even less typing, in my opinion.